I figured, I don't know, most of the periods we didn't quite get time to work together, and hopefully we can avoid some confusion if I work through a bit of this and make a video. So let's see if this helps. So AP Calculus Problem Book 1.1, Rates of Change. We're going to find the formula for the average rate of change of the area of a circle as its radius r changes from 3 to some number x. Okay, so I guess, shoot, there you are. Okay, average rate of change means we're going to have something, output minus output, I'm just going to put that structure in, over input minus input. I suppose the next thing to focus on is this tells me it's the average rate of change of the area of a circle. Area of a circle is pi times the radius squared, and that's, when we say average rate of change of, whatever follows is the function that's going to be kind of the output variable, if that makes any sense. So we could say area minus area, but that's not terribly important or useful or whatever. So what instead we're going to do is have pi times something squared minus pi times something else squared. So to me that looks like we have average rate of change because we have that structure, y minus y over x minus x, whatever you want to call that. In this case it's area minus area over radius minus radius. Anyways, next color. Okay. As its radius r, so we're not going to use r, you'll see in a second, changes from 3 to some number x. So the radius starts at 3, ends up at x, 3, and x. So maybe I should give this a label. This is the average rate of change of the area of a circle, there we go. Oh, now we lost the r. From radius equals 3 to radius equals x. And maybe I can even simplify a little bit to get rid of a few things. Let's say pi x squared minus pi times 3 squared. I'm just going to leave everything, x minus 3, as they stand, because what I want to do is use a calculator. If I'm using a calculator, I'm going to let it do everything for me. Okay, so that's my first bit. I'm going to change back to blue because blue is easier for me to read. So then part A. Maybe I'll do it here. A, radius. I think everyone would know r is radius. Radius equals 3 to radius equals 3.5. You just realize I didn't read this with you. It says, then determine the average rate of change of the area of a circle as the radius r changes from 3 to 3.5. So what you're supposed to realize is, oh, we made a formula for that. Okay. So we always need to show where things come from. And really what this means is, you'll see here, 3.5, 3.2, 3.1, and 3.01, that's what's going to go into x. And notice the starting radius is always 3. So we can actually use this function that we already had. So let's see if we can get calculator going. And of course it starts on the wrong screen, but that's okay. So while that's loading, I'm going to write what I would put in to my formula. So instead of pi times x squared, I'm going to say pi times 3.5 squared minus pi times 3 squared over 3.5 minus 3. And to me, I think that's really nice and clear and obvious because, you know, I have this rate of change expression. I've labeled 3 and 3.5, and it's, to me, very clear those go together. Okay, calculator's ready to go. Error. So, I realize I'm going to be typing the same thing in a few times. So instead of doing pi times 3.5 squared, and maybe I will, but then I'll do the other one, minus pi times 3 squared over 3.5 minus 3. I don't think this is a great... Oh, gosh darn it. Delete. Minus 3. One thing I think is a good practice is to type everything all at once and just press enter. So I could type, or I could write down on the other page 20.42035.255. 4.203, what was it? 35255. Okay. But because I'm going to do 3 to 3.2, 3 to 3.1, 3 to 3.01, instead of doing that, I'll just define a function here in y1. So I am going to do pi times x squared minus pi times 3 squared over x minus 3. And then I can just call that function. That's what we wrote. I can call that function up here if you have an 84 using F4. So I want y1. I'll evaluate y1 with 3.5, which means I'm going to put 3.5 where those x's were, and I should get the same, 20.420. Which is nice because I know I'm supposed to put 3.2, well, the average, the rate of change of the area of the circle from 3 to 3.2. Which just means 3.2 is the input, and I already have the number. I just need to write something here. So I'll write b, radius equals 3 to 3.2, pi times 3.2 squared minus pi times 3 squared over 3.2 minus 3. And then I just need to copy down 19.47787. 445. Cool. And then I'm supposed to do from 3 to 3.1. Maybe I'll just keep going vertically. R equals 3 to R equals 3.1. And that's going to be really easy to type in my calculator. All I have to do is tell it, hey, use 3.1 where I put in those x's. So I'll just call y1 and put in 3.1. All right, so again, that's F4. But if you didn't know, we can just highlight, press enter, bring everything down, and I will just overwrite that 3.2, 3.1, press enter, 19.1637. And remember, it was a 1, 519. And then I believe the last one is R equals 3 to R equals 3.01. Yep. Okay. Pi times 3.01 squared minus pi times 3 squared over 3.01 minus 3. And we'll just go up. Oh no! Don't change workspace. I have no idea what I just did. Don't change workspace. Oh man, what the heck did I do? Okay, anyways, 3.01, 18.88097. $185. Okay. So I guess the other thing we're supposed to realize is you're kind of doing a numeric limit here. These y values, oh man, I copied that wrong. Huh. Well, if I look, 18.888, 19.163, 19.477. I bet this was 20.4. You probably already noticed I don't know how to read. So the nice part about 20.420, I jumped some numbers there. That should be 20.420. 20.420, Okay, so that should be good. That was super weird. Anyways, so 20.4203, 19.477, 19.163, 18.888. Notice we were actually almost doing a numerical limit, or the beginnings of it, 3 to 3.5, 3 to 3.2. We're kind of doing, I'm going to erase this here in a second, but we're kind of doing the limit as x approaches 3 from the right-hand side of this pi x squared minus pi times 3 squared over x minus 3. Doesn't really matter that we're doing that, just wondering if you noticed. Okay, that should be enough to get you started. Have a great night.